Here's a sample problem from the textbook, from the ebook. So this is sample problem 1.8. This is an example of dimensional analysis. In this particular problem, we're going to look at doing a conversion from what's called the SI system into what are called imperial or English units. So let's read the question here. The Food and Drug Administration, the FDA, recommends that dietary sodium intake be no more than 2,400 milligrams per day. What is the mass in pounds? And here it says that 1 pound is defined as 453.6 grams. So in this particular problem, notice that there is a conversion given to you, the pound to gram conversion. In general, we don't expect people to memorize the imperial to SI conversions or vice versa. But we do expect people to be able to do the prefixes. So you'll notice that the recommendation in milligrams has a prefix milli there. It's 2,400 milligrams per day. So let's go through this. What we see is that I'm going to take the measurement that's given. The measurement is the first number given here, 2,400 milligrams. And we have a conversion that's given. So I'm going to write here that this is given. That we have a conversion which is 1 pound LB is equal to 453.6, not milligrams, but grams, and that's the key to this particular problem. The conversion factor that we're given is between pounds and grams, not between milligrams and pounds. So let's try this strategy. The first step is what we're going to do is we're going to convert milligrams into grams. And then once we've got that into grams, now we can use our given conversion factor to go from grams into pounds. Okay? So let's go through this step by step. What I'm going to do is I'm going to write in the first step that 1 milligram is equal to 1 times 10 to the minus 3 grams. So what I've done is I've said that milli is 1 times 10 to the minus 3. So 1 milligram is 1 times 10 to the minus 3 grams. Okay, there's our conversion factor there. So now let's go ahead. We have 2,400 milligrams. That's the given piece of information. And then we're going to use dimensional analysis. This is our first problem of really looking in through dimensional analysis. We want to go from milligrams to grams. So if we have milligrams up here, we need to have milligrams down here. So I'm going to take the 1 milligram, I'll write that over here, and put that in the denominator. And then I'll take the 1 times 10 to the minus 3 grams, and I'll put that in the numerator. So notice we have grams divided by milligrams. Okay? And we have milligrams up here, so milligrams divide out with milligrams. That ratio is equal to 1, right? 2 divided by 2 is 1. X divided by X is 1. Milligrams divided by milligrams is equal to 1. So the only unit that we have left over is grams. So then it's just an issue of writing it out. Now, in fact, because we have 1 times 10 to the minus 3, we could actually write this in exponential notation as 2,400 times 1, well, we don't need to write the 1, minus 3 in grams. And there's nothing wrong with that number. It's not in what we would call scientific notation. Scientific notation is a number where we have 1 to 9, 1 through 9 times 10 to the x. Well, this is 2,400 times 10 to the x, where x is minus 3. So what I'm going to do here is I'm going to go ahead and pull up my eraser here. Oops, sorry. And try to erase that. Oh, sorry. get rid of that there. Okay, so now we have this in grams, which is what we wanted to have it. Now we want to convert it into pounds. So our second conversion is grams to pounds, and the conversion factor is 1 pound is 453.6 grams. So in step 2, 1 pound is 453.6 grams. So we have grams, 2,400 times 10 to the minus 3 grams, but we want to get rid of the grams. So we don't put the grams in the numerator, because if we put them in the numerator, if we put grams up here, we'd have grams times grams. We don't want grams times grams. We want to get rid of them. So we put the 453.6 grams down here so that the grams cancel. And then we put our 1 pound here. Oops, 1 pound. There we go. So now grams will cancel. And the only unit left over is pounds. So now we enter that into our calculator. So 2,400 times 10 to the minus 3 times 1 divided by 453.6, and you get 5.291 times 10 to the minus 3 pounds. So I'm going to write that over here, equals 5.291005 times 10 to the minus 3 pounds. Remember significant digits or significant figures. Everything that we did here in this problem was multiplication division, no addition subtraction. So that means we use the guidelines or the rules regarding multiplication division, which says that your answer cannot have more sig figs, a greater number of significant figures than any of the measurements. So there's a little bit of ambiguity here. This one is 2,400. I'm going to make the assumption that those zeros count. So this would be 4 significant figures. And 453.6, this is a definition. 1 pound is exactly 453.6. So this essentially has an unlimited number of sig figs. So it looks like it's 4. Now you might argue, well, wait a minute, that 2,400 milligrams only has 2 sig figs because the zeros don't count. It's ambiguous, but I'm going to go ahead and assume that they do count, so we would want 4 sig figs. So that would mean that we round it to 1, 2, 3, 4. The number that comes after the 4th digit, which is a 1, the number after that is a 0. That's certainly less than 5. So we can round this to 5.291 times 10 to the minus 3 pounds. Okay? So 5.291 times 10 to the minus 3 pounds. If you're going to be a stickler and argue, wait a minute, I don't think those zeros count, then we would round it to 2 sig figs, and this would become 5.3 times 10 to the minus 3 pounds. So notice what happens here. In pounds, the amount of salt, or sodium I should say, the amount of salt, I'm going to write the answer over here, the amount of salt that you need is really a very small number, 10 to the minus 3. So that's not a convenient unit to use for measuring sodium intake for a human being. That might be the correct unit, pounds, if you're talking about someone buying a lot of salt to throw on the roads or something like that. We might want 50 pounds or 60 pounds of sodium chloride. However, if we're talking about the amount of sodium that one person is taking in a day, it's pretty small, so it's probably better to use milligrams, right? 2,400 milligrams. That would be a more reasonable number to be able to report. Okay, so there's the sample problem. So practice all of those. Make sure you do the practice. This is the sample. Do the practice ones and the checkpoints. And then if you have time, try to do some at the end of the chapter as well.